Good evening, guys. So let me start by introducing myself, guys. So my name is Neeraj Kheria. All right, guys. So let's get started on our discussion on cybersecurity. Now, cybersecurity, if we have to divide cybersecurity, then it refers to everything that is digital. That means it requires the, and now, first of all, why exactly cybersecurity is required, right? And cybersecurity is simply that refers to everything that is digital. It requires the understanding of how a network runs, because once we have a deeper understanding of how a network performs, what are different constraints, what are different methodologies used in a network, how the networks are connected, what are different firewalls involved, then only we can work in cybersecurity domain, right? Then the term cybersecurity also refers to the art of hiding and encrypting information. That means if we do not want, now we have multiple data packets, right? Now we do not want those data packets to be transferred to any third party or any other unknown sources, right? Even though what we do is we simply encrypt different piece of information, so that even though the same data packets are being transferred to other parties, then they will not be able to decrypt that, because we have encrypted using a simple key itself, right? And then it requires the understanding of cryptography. That means what are different methods of encryption. First of all, what exactly cryptography is, in which context we have to, in which kind of use case cryptography works really well, and how we have to execute this for securing the data being shared across network. All right. Now, the agenda for today's session would be to discuss on the packet structure. Then we'll move on to discussing on the complete architecture for network, how any network is designed. Then we'll discuss on different methods for addressing the network. Then we'll discuss what exactly we mean by IP and the MAC. Now, these two terms you must have been aware of. Like we have an IP address and we have a MAC address. And what exactly is the setup of these both? We'll see to that in detail. Then we'll discuss over the firewalls. That means how many firewall types are there and what are different methods of making sure that our network is secured using firewall. And then we'll discuss on symmetric cryptography, and then we'll focus on cryptography. And then we have two different types of cryptography. Here, first of all, we have symmetric, and then we have asymmetric cryptography, right? So that will be our agenda for today's session and our discussion on top of cyber security. All right. Now, getting started, first of all, we have network part, right? So first of all, how exactly we download any files, right? Let's suppose we download any files or we access any website. So what happens is, let's suppose now all the file systems that we want to access, be it any, even if when we have any website, when we are accessing any website over internet, or let's say when we are downloading files in different formats, including JPG images, including videos, documents, the ISO, that means the disk image files, and any zip folders. So these are all available on a server, and from which we can download a copy which is available in the server into our own systems, right? As different packets. So for example, now this is also moreover the same thing that on what email is based on. Now in email, again, we can choose. Let's suppose here when we are downloading any file, we do not remove the copy of that particular file over the server, right? So what we do is we simply allow the users to download a copy of the file that is already stored on the servers, right? Whereas if we talk about emails, right? Now we can have the setup that means once the copy of the email is downloaded from the server, the same copy should be removed, should be deleted. The same option is available in Outlook and other desktop-based email applications as well. That means once the email is being downloaded from the server, it should be removed, especially when we are using POP or IMAP services for emails, right? Now, next is we have data packets. Now, first of all, what exactly packet is built of? First of all, we have the packet trailer, then we have payload, then we have packet header, right? If we talk about packet header, then it simply contains all the critical information regarding the packet. For example, what's the source address, what's the destination address, that means from where it has been generated, and what's the destination for which it is intended for, right? What is the type of service, the version information, all of these information are present inside the packet header. Next, we have payload. So payload is simply the data itself, which is being transferred, right? This can be anything. This can be video, media files, document, or any other executable files, right? So payload is simply the file itself, which is getting transferred. And now if we talk about packet header, now first of all, we have something as IP4 version. That means this is the version of the current internet protocol being used. Then here we have the header length. That means it's the header of the entire IP address. Then we have something as DSP, that is differentiated service cloud point. This simply specifies what exactly the type of service that we are using. Then we have something as ECN. ECN is simply the explicit congestion notification. That means it simply contains information, how much congested, how about the traffic any particular route is facing. And in case there are some kind of issues, again, that can also be stored as a part of ECN. Then we have the total length. Now, total length is the length of the entire IP socket, or we can say IP packet, including the IP header and the IP load itself. Then we have something as identification. Now, basically what identification is, if we divide the entire IP packet, we have multiple fragmentations. If it gets broken down into multiple components while being transmitted, right? That means that then each and every of those fragments will be containing the same identification number. That means whatever was the original identification assigned while they were traveling, even though when they get broken down, they will all share the same original identification number, so that it can be reused to recollect and combine all the different components together if they share the same ID, right? Because if the ID is not same, then again it will create an issue for combining or for comparing all the data together. Then we have something as flags. So basically it is required by the network resources only in the condition if the packet is too large to handle, right? That means now suppose if the packet is too large, suppose we are transferring a big media file, for example a big video file, again then it has to be broken down. If the entire packet cannot be transferred in one go, then it gets broken down, and that is decided by flags to see the feasibility. If it can be broken down, it will be, or it will be kept as a single packet itself, as a single payload. Next is we have fragment offsets. So this is exactly, now this contains information about the position of the fragment. That means where exactly they are located when they are being transferred. Then we have time to live. That means now we do not want entire data packets to go into a loop inside the network, right? And that's why we have time to live. That means each and every packet is sent with the time to live. That means it will contain the time information, and that tells the routers in how many routers can this packet cross. That means suppose we have broken down the entire payload into 10 packets, and this will contain the information for it as well. Next, we have a protocol. So it simply tells the layer the destination host. That means the address, the destination host for which this entire packet is customized or is built for. Next, we have checksum, the header checksum. So this is basically used to keep a check on the value of the entire header. Now, once the packet has been delivered, there may be some kind of misplacement. That means suppose the entire packet was divided into 10 packets, right? So we have to make sure that each and every of those 10 packets have been received. There is no missing packets, there's no missing parts in it, and if they are, then they should be also included in the final delivery. So these all piece of information is stored in header checksum, right? Next is we have the source of IP address. That means the IP address of the sender of the packet. That means from where it has been originated. The destination is for where it is intended for. That means the recipient address. It can be any system, it can be any devices for which it has been meant to be sent across. And then if we have some kind of additional options, then again it can be visible here. So again, suppose for example, if we have included something as timestamp, if we have included something as security routes, that means preferred route, all of those will be available as a part of options. All right, so clear on this part, everyone? So these are different components as a part of IPv4 packet. And again, currently we are using IPv6 as well as a standard, and this is basically used for IPv4. And currently we are also using IPv6 as well. Now, next is we have something as OSI model. Now, this simply defines that this is what is being referred as an open systems interconnection model, and this simply defines it is basically useful for understanding how the computers communicate with each other using this particular diagram, right? So it simply defines the flow of how the computers communicate with each other, right? It is also referred as a layering model, which consists of 7 layers, as we can see here. At the bottom itself, first of all, we have physical, then we have data link, then we have network, transport, session, then we have presentation, and then we have the application layer. Now, first of all, if we start our discussion, first of all, we have application, transport, internet, and link, right? So application layer simply allows the application to access the service of other layers. That means we have 6 more layers apart from application, and it simply help the users or have to access all of these layers one by one. Now, for example, let's suppose when we are using a browser. Suppose now browser can be of any provider, like we have Safari, Internet Explorer, Google Chrome, and we are using it to access a web server, right? Now, if we want, we can type in the address in the browser, either in the HTTP or HTTPS. Like we must have seen, whenever we are typing in any address, right? We can type in both HTTP or HTTPS as well, and so that the browser can send a request to the server to visit the web page, right? Again, that means now here we can have multiple functions, and these kind of applications can include a multiple functions, like we have encryption, we have authentication, and again how data is displayed. And if we talk, and again, that's why we have, if we talk about the most widely used application layer, then we have the hypertext transfer protocol, right? That makes the pages of the World Wide Web. Then we have file transfer protocol. It is simply used for transferring the individual files. Let's suppose we have an entire website and we want to play around with, we want to change the file content or file type or upload or download any file. Then we have file transfer protocol, popularly called as FTP. And at last we have the simple mail transfer protocol, as in SMTP service, which is a main driver for sending out emails, right? So it is basically used as a protocol for email services, for sending out emails and for checking for the attachments. All right. So HTTP is used for web pages, FTP used for sending files in and out, and then we have SMTP for sending emails. Then we have transport. Now, transport layer is basically the host to host transport. Now, if we can refer this as a host to host. So transport layer is simply used to make the connection to the server, where now basically it is more reliable because it is a three-way connection with the web server, right? That means it can make sure that all the components are delivered properly and we don't get any kind of errors while accessing the page itself. So it is basically, it provides one-to-one connection, or it is one-to-one connection, it is connection oriented, it is more reliable, and in here we also follow multiple sequences and knowledge packets. Now, in contrast to TCP, that means the TCP model, ODP offers one-to-one to many connectionless unreliable communication service. That means even though someone are not secured, someone is not reliable, that means it may break down multiple times. It can be used to connect to those services. And ODP is basically used when the amount of data to be transferred is, we can say, almost the same that can be used to fill in a single packet. And then when we have the TCP connection established, then it depends upon the system itself how much data can be stored here. And TCP and UDP are used for both IPv4 and IPv6 interlayers. Now, as we know, currently we are using the IPv6. And internet is basically the layer on which the entire websites are running. So again, it simply offers responsibilities to or to handle packages and for routing functions. And that's why we have IP address as a part of internet, the internet protocol address. that is an address that can route the fragments and then can reassemble the packets when it has been broadcasted. So suppose once one particular layer has been broadcasted, then we can import the same into WordPress, or and then we can make sure that we are using the same IP address. Then we have the Internet Control Protocol. That means it simply reports the errors in case we are facing anything. Then the same kind of errors can be, the log for those errors can be reported for this unsuccessful packet delivery. Let's suppose the TTL got expired. Then for using that, again, we have different services. And that is being presented in which layer? In the internet as well, as a part of IMCP. And at last, we have the Internet Group Management Protocol called IGMP, which manages multicast groups based on IP addresses. Right, so for example, now if we talk about applications, so this is basically where the user will be needing the application to transfer the data among hosts. For example, HTTP, File Transfer Protocol, the electronic mails, these are all a part of application that we discussed just now. Next is we have presentation. That means it will simply help to make one host understand the other, right? That means data sent here is converted on wire data, and the receiver's end is converted back to the native format by the receiver. All right, session is simply the connection between the server and the system for websites, for different applications, right? That means whenever we are sending anything over session, that is required only once. For example, this must have been observed when we are performing any online transactions, right? So whatever we enter, let's suppose we have entered the details for our credit card, we have entered the CVV, we have entered the expiry date and the OTP as well. Now, once we enter it, that's why it says, now you must have observed there's a clear-cut warning that do not press back or refresh when the transaction is being taken place. So basically what happens is whatever data has been recorded, we do not wish to re-enter. That does not need to be re-entered by the user, and that is transferred, or that is transmitted securely through this particular session. And that's what happens when we have session as a part of Internet Protocol as an OSI model. Then we have transport. Now this layer simply provides end-to-end data delivery among hosts. That means this makes sure that it is a stable delivery of all the packets that has been initiated and it reaches till the destination in this particular layer. Then we have networks. This layer simply helps to identify uniquely the host beyond the subnets and define the path which the packet will follow. And next we have data link. So data link is simply a layer of the raw transmission data. That means from physical layers, and then we have to convert this into data frames. We have to send this back and forth to the upper layers, and then we check out if there is no any transmission error in this particular data link. And then last we have physical. So it simply deals with all the physical hardware and technology that is required to keep the communication up and going. Like we have cable type, we have voltage, we have signaling, and multiple more modules. All right. Next is we have something as unicast, right? Now in unicast, what happens? Basically, it's simply a network where we have a single sender. That means, as we can see here in the center itself, what we have a single sender and we have multiple receivers for the same set of files, whatever we are sending over the network here. For example, here we have a single sender and same file can be shared across multiple networks here as a part of unicast. Whereas if we talk about multicast, or we can say broadcast, then same file when being sent back to the server can be broadcasted into other system as well. That is what we mean by broadcast, right? So unicast is when we are sending to only one system, and broadcast is when we are sending to multiple. So here we have two different types of addressing. We have unicast and then we have broadcast. In unicast, what happens? Unicast is what we do is as a part of single system. Let's suppose when we want to send a data to only a single system in the network, then what we do, we unicast. That means, for example, if this system wants to send something to this system, then what we have is we have a unicast. We are doing a unicast, right? And when we want to send the same set of files across multiple platforms, then what we do is we simply broadcast. That means once the original source uploads the file to the server, then that is being sent to multiple systems as a part of broadcast, right? And then we have multiple casts. That means here we do not send the data packets to every system. Again, we send this to multiple systems that we have selected, right? Unlike broadcast. Now, next is when we are visiting Google. So again, it simply works in three-way handshake. For example, let's say what we are doing is we have connected to the internet. Again, the internet then connects to the server on where the file for the website or the application that we are trying to access is stored. Again, it comes back to the internet protocol, and again, the data is being rendered on the system on which we are accessing. And that's how it works in terms of internet services. Again, if something needs to send back, again, the same packet is sent across internet and sent to the servers. And again, same thing gets returned back to different systems altogether. And that's how we connect with the server on which the file is being stored, whatever website or whatever web applications we are trying to access. Now, next is when we talk about the address for any system, then basically every system will be having two type of addresses. One is we have for IP address, whereas the second one we have for MAC address. IP is simply a unique identifier number that is being separated by full stops. IP is simply the Internet Protocol address. Now, this is assigned by us by the ISP, that means the Internet Service Provider, and this will be unique for the network that we have the access to, right? Whereas if we talk about MAC address, and MAC address is simply the, you can say, Media Access Control address, right? Where it is used to uniquely identify the system which is being a part of the network. Suppose whenever we are setting up our home routers, right? Then we simply get the MAC address. Suppose if we want to limit, if we do not want to allow that particular device, whether it is a phone, whether it is a laptop, or any smart televisions, because each and every device running on internet will be having a MAC address as well, right? So if you do not want that particular system to have the access to our network, then we can disallow them. We can block them using the unique MAC address, right? Now, MAC address are unique. That means no two devices can have the same MAC address. Now, although they all can be running on the same IP address because they all share the same network, but since these are different systems, that means they will be having different MAC addresses. That's why MAC address is unique in order to identify a single system altogether. So that's why we can use MAC address, right? If you know the MAC address of the system, then we can use it to block or allow the access to any network. Now, then we have address resolution protocol. That means if we wish to see which one is this particular 33, again, that means that can be pointed out. We use the MAC address to communicate effectively among different systems, because if we use the IP address, then the same as we discussed, IP address may not be unique, right? So multiple systems can also be sharing the same IP address, right? And just to make sure that we communicate, we send the data to the right machine itself, then that's why we use MAC address, right? And that's why we have a common issue, and this is a common issue because the same way we can have multiple data networks. Suppose the same IP address belongs to multiple systems, then that data can be transferred to the wrong system as well, right? And that's why we need to have a man in the middle, right? And this term is commonly called as MITM. What exactly it is? It simply impersonate the endpoints in an online information exchange. That means if data is being sent to some other system, then it can work as a middleman to fetch the same piece of information because of the same address, right? That means now, as an example, let's suppose when we are banking online, we can have a middleman in our entire setup that will impersonate, okay, that they are the bank server itself, right? That means the man in the middle will receive all the information transferred between both the parties. That means between the actual user and the bank, and they can use this kind of sensitive data to perform the same transaction again and again, because now they have captured the username, the password, all the account information that has been entered by the user, and then they can use this piece of information for further transactions. So there'll be a third man, we can say a man in the middle, which will be receiving and sending data across, which was meant to be shared among two different systems altogether as a part of man in the middle, right? And that's exactly is a situation, is a perfect use case where cybersecurity comes in. And that's why we have what we can set up a multiple firewall system. Firewall is simply a network security system that monitors all the data that is being sent back and forth through any network, right? So whatever data is being sent back and forth, whatever is downloaded and uploaded, that is monitored using firewall. So firewall is a basically combination of packet filtering firewall, then we have application proxy firewall, and then we have a hybrid firewall. When we are talking about packet filtering, again, let's suppose when we have multiple systems, and we are downloading data from multiple systems, then these are again obviously delivered as a part of packet, right? And whenever it passes on through the firewall, for example, here we have multiple data sets coming in, and once all of these data packets go through firewall, only those packets which were safe, only those are delivered, and the unsafe packets are dropped, not delivered to the system. And that's how we get multiple warnings that okay, something tries, or we had an infectious file, or it was trying to access our systems, and that's why the access has been blocked, right? So that's a main usage of packet filtering firewalls. Now, if you move to application proxy firewall, it's simply a system that simply protects the resources by filtering messages at the application layer. Right? We have seen multiple layers that we have, right? So it filters all the messages at the application layer itself so that we don't have to filter out each and every packets differently. Then thirdly, we have the hybrid firewall, which is a combination of both application and packet filtering firewall. Again, and that's why they're applied in series. First of all, we have application, and then we have packet filtering firewall applied to our system. Then we have hybrid firewall that we have parallel. That means here what will happen now in here in hybrid firewall, we had this one now both application and packets set as parallel, right? Whereas in here we have this set in a series itself. That means first of all going to application, then packet again. If required, it will be sent to the application or it will be transferred to the destination. Next is we have cryptography. So cryptography is basically that we must have studied in the IP for a school and in our colleges as well. So cryptography is basically the process of converting the plain text into a coded text, or that means in a format that cannot be understood by any human being or any system until and unless the key which was used to encrypt the data is available, right? That's the concept of cryptography. Here in cryptography, what we do is, for example, here we have a plain text, then using a secret key, we encrypt the entire text available in that document, right? And here the converted text is called as a ciphertext. And now, once the ciphertext again needs to be decrypted, that means once we have converted this to ciphertext, then again we can send this file across network along with the secret key, and then anyone receiving this entire ciphertext, they can decrypt this. That means they can decode the ciphertext using the same secret key that has been used to encrypt that and convert the ciphertext back into plain text, right? So that's the format we use for cryptography. And suppose here we have the original data, then again using encryption, we can scramble data. So here what we are doing is we are converting this to cipher, and here in this second method, what we are doing is we are simply scrambling the entire data part. That means here we are rearranging, we are throwing each and every letters separately. And again, using a private key, again, we can decipher it. That means we can convert this back into its original state. So these are the two different ways or types of cryptography through which we can make our data secured, especially when we are transferring the data, right? And this kind of setup is called as symmetric cryptography, as you can see here. And now symmetric is basically when we have a plain text. For example, here we have the quick brown fox jumps over the lazy dog. So here we have the keys for which we are using this to encrypt. Now we have a ciphertext. That means each and every letter has been converted. The entire text has been converted into a ciphertext, right? And again, if we want to convert the same ciphertext into the normal plain text, then we need to have the same secret key through which we have converted this into cipher. Because if we lose out this key, then again, this cannot be converted into a plain text. Now, that's why keys are really important in cryptography, right? And that's why we have two processes involved, encryption and decryption. And key is basically used to both encrypt and decrypt the data, right? So we have to keep the keys as well secured when we are working with data. And this is a key that we have used for converting the plain text into a ciphertext, as we have discussed. And public key cryptography is, suppose when we want to send something, we have the transaction message as a secret key, and these are digital signatures that is being added to the content. And now what we do is, now we have the transaction message, again using the same public key being shared by the sender, and then we have this one being decrypted and stored, received well by the receiver. So public key is used for encrypting data and private key is used for decrypting it. All right, guys. So thank you so much for joining the today's session here, guys, and have a great day ahead and hope to see you all soon. Thank you so much.